Hello everyone, how are we doing today? It's an, is a pleasure to actually be speaking with everyone today, right? So I mean, it's it's nice to get to meet everyone today and coordinate the session for today. I mean, I'm in the midst of one of our senior men in the house, right? And today we're going to be looking at an interesting topic, right? We're going to be looking at an interesting topic, and I know you're going to enjoy the session. So I'll be having no other than one of our MVPs in the house. Also, he is a leader of the Azure Nigeria community, and he's going to be taking us on designing Microsoft Azure infrastructure solution. Right, I'm sure you must have heard of him, but let me formally introduce him. His name is Sir Kofi. Sir Kofi is from Ghana, and he does wonderful things for us here in the community. And today he decided that he's going to you know teach us about Microsoft Azure infrastructure solution. So I'll be bringing Sakofi on stage so he can begin to dish out some of this menu he has prepared for us today. And I'm sure, I know, it's going to be very interesting. So, hello, Sakofi. How are you doing today?
Yeah, I'm doing great. It's lovely to take this opportunity to join this program. I know it has been going on for quite some few months now, so I'm really excited. And I'm one of it was a wonderful introduction, by the way. Promise.
What a pleasure to have you in the house. Like, you know how when you see, like, one of those mentors you've been looking forward to working with, learning from, having them on the platform and discussing and sharing their knowledge with you. I mean, I would say it's just a great pleasure. So at this point in time, in order not to take more from the allotted time you have to take this session, I'll give you the forum to go ahead and do your thing. I mean, I'm going to be having my biro, my pen, and I'm just going to be jotting down, and also letting everyone know that if you have any questions for Sakofi while he's taking the session, please just drop them in, and I'm going to create some form of question and answer time before he rounds up the session. So, Sakofi, over to you, sir.
All right, thank you, Promise. Hello, everyone. Thank you for taking the time to join today's session. It's been a great weekend. I know you're all enjoying your Easter break, but still, it's good to really just get some knowledge in as well as part of the process. So, without any further ado, let's get into what we're going to do today. So, for today, the agenda is to look into designing Microsoft Azure infrastructure solution. So, as part of your preparation for your AZ305, you need to also know how a network are designed in the perspective of Azure, inclusively to your on-prem as well. So let's get into it. So, as always, we start with the title, Designing a Network Infrastructure Solution. So what we're going to do is to look into some of the network architecture based on your workload. We also look into design basically on your connectivity to your on-prem environment as well, from your Azure resources to your on-prem, most noticeably with uh, virtual networks. All right. So we also look into application delivery services and also designing application protection services, because nowadays you cannot go on deploying things to the cloud without considering security. So we also cover that angle as well. Okay, so let's look at some of the recommendation when it comes to network solution on your workload. So one of the things that we always consider is having security in depth. So we will look into some of the strategies and the solutions that we do have on Azure to help protect your solution in the cloud, and also how you can also protect when you are accessing the resources from your on-prem to the cloud. So we look into like security in depth, protecting the data, ensuring that there's security in the application, security at the perimeter, security in the network, and also implementing of identity and access. So let's look at some of the network requirement when you're planning a virtual network. So when planning deploying a network or designing a network in a cloud, there are a few considerations. You need to think about the naming. It's quite a very important aspect, because what you need to understand is that when you're creating a resource, it's not just going to be something that you are going to administer alone. You probably have to think about, let's say, third parties that might come into your network to probably help you to configure or probably integrate certain solution to those network. They need to understand what they are working with. So knowing and making sure that you name those resources appropriately will go a long way. And even having description of these resources and then documenting it will really go a long way. Another key point is a region. Where you are deploying your resource have to be taken into consideration. Nowadays, many companies are moving to the cloud, but another key element that they keep thinking about is data sovereignty, in making sure that their data are saved in a specific region. So, for example, if they are based in Europe, more likely want their data to be in Europe or even close to the country they are from. Right. So then the data sovereignty become a very important topic here. So you need to have that into consideration. Certain data need to stay in a specific locations. You need to factor that into your network design. Another key point is subscription. Subscription can be used in many ways. Most often, companies will use it based on specific, let's say, teams in the organization or department. They will have certain Azure subscriptions tailored to that specific team, so that it'll help them to understand the level of usage, the cost attribution to the service they are using in Azure. Another key factor will be based on workload. You probably will have different projects going side by side, and you might attribute subscription based on those specific projects. You could probably also base it upon your production environment, your testing environment, and development environment. All of these specific environment might have different subscription attachment, so that it's easier for you to really also measure, understand the scope, understand the resources that are needed for all those specific environment, which could also help you to understand the cost attribution, know how much those resources or those specific environment are costing you. Because creating those separation might help a lot to have a clear understanding the cost affiliations in regards to those environment. Another key factor is segmentation, right? On-prem, we do segmentation already with your network. You more likely will segregate your servers and separate them from your normal host computers. You might segregate, let's say, your SQL or database service into a specific subnet, and you might have your, let's say, mid-tier in a different subnet. Creating those separation help you to implement level of security, because more likely those type of service might need specific ports or service to be open. You don't want to be opening up all the ports on those specific subnets. So by creating those segregations, you can only open up ports that are relevant for those services, so that other ports will be blocked, which will create level of security. Another key point is that in terms of administrations, let's say email service, you more likely have specific colleagues in the environment that do only emails, so you can only give them permissions and the roles they need to do their work. And then any other person that do not require those roles, you do not allow them access to it. So creating those segregations add a level of security. So, for example, if a bad actor managed to get into certain part of subnet in your environment, they are less likely to also use lateral movement to get into other subnet if you've created these sort of segregation and implement good level of security in the midst as well. Another key thing is that you have to consider when it comes to the network requirement gathering. It's all about security, knowing how to implement a network security group using firewalls to have some level of security. Those things goes a long way. Even with Azure, you can use Azure Bastion to ensure that only when people are accessing your resources, they will use the Bastion service for that matter. We're also looking to connectivity. So in terms of connectivity in your environment, how do you access those resources? You more likely will have to use, let's say, something like a VPN or express route to get access to those resources you have in the cloud to create some level of security. Permissions, like I said earlier, when you have an environment, you have to think about RBAC, whereby you give the people in the environment the least amount of permission they need to do their job. All you need to do is just give them enough permissions for them to be able to do whatever they need to do. You also have to look into policies, right? Because when you're creating a network, and you have to, if you're thinking about, let's something like data sovereignty, you want to have some sort of policy in place to use an Azure policy to prevent people from creating resources at any regions that they want, but restrict them to using policy to specific regions that they can really create those network resources. Designing for on-prem connectivity to Azure virtual network. So when it comes to designing to ensure that you can connect to those resources from your on-prem network, one of the key things that comes in mind is VPN. So VPN gateway, so it's a type of virtual network gateway that send encrypted traffic between an Azure virtual network and on-prem location through the internet. So these traffic are encrypted. So even though the traffic is going over the public internet, they are encrypted, and it's more like creating a tunnel straight to those resources in the cloud. And you have a VPN concentrator at your on-prem and another one at the Azure end. So there will be a VPN gateway on-prem and a VPN gateway on your Azure as well. So having that, you have that level of security, ensuring that those data are encrypted. So even if someone eavesdrop on those communication, it's just going to be more like it's not going to make sense to them, right? So one of the key benefits is simplicity. In terms of VPN, it has been there for quite a long time. There is many types of VPN. What mostly will be implementing this scenario will be IPsec VPN. So implementing the IPsec VPN is straightforward. It's been a solution that has been around for more than 30 years. And with this VPN, you have up to 10 gigabytes depending on the VPN gateway, right? And the few challenges will be it require an on-prem VPN device. So that means your on-prem needs another VPN concentrator. So you might probably have an on-prem firewall that have, UTM, these sort of firewalls that have multi-functions. It might have a VPN component, and then you can then use that one to set up a VPN to the Azure side. Another key point challenge is the SLA. So the SLA only covers the VPN gateway and not the network connection to the gateway and the throughput. So that's one thing you have to bear in mind. Moving on, Another way to connect to your Azure resources using the Azure Express Route or the Azure Express Route Direct Connection. So the Azure Express Route connection use a private dedicated connection through a third-party connectivity provider, right? So essentially what this one will do is that there will be an ISP that have that provision these services. So when you go to Microsoft website, they will have a list of um, providers around the world. So meaning that all of these uh, ISPs, they have been vetted by Microsoft, and they can provide the local edge router from their end to connect to Microsoft Edge routers. So as you can see from the diagram here, the local edge routers will be from your dedicated ISP in your specific country, and they will now set up a Azure Express Route circuit to Microsoft Edge routers to establish the connection. And most of these sort of like connections are also redundant. There will be a primary line and there's be a secondary line connection to create a level of high availability. But one of the key elements is that up to 100 gigabytes of bandwidth are supported as well in this, and they are global reach. So that means traffic over the private connections are more like can stretch over the other regions that Microsoft provide. Because once the traffic get onto Microsoft edge routers, then it can then leverage on the Microsoft backbone to then send the traffic to the other regions that Microsoft have. And in terms of the availabilities, have about 99.95 availability SLA across the entire connection. One of the key challenges that you see when it comes to the express route is the complexity of setup, because you need to know that there's a third party involved in terms of this setup, and that can also create a level of issues from their side as well. If you don't want to use the third party, there is what we call the express route direct connection, but those are specific regions that have these direct connection. That means the connection is directly to Microsoft edge routers, but it's only at specific locations. And one of the key things to understand, to know about, is that this require high bandwidth routers on-prem side. So that means in terms of the cost factor, you need a high bandwidth router on the on-prem to support this capability. Right. So we've talked about VPN. Also, we talked about express route. Right. And yes, you already know one of the key things that you need to know and also you need to have when it comes to networking is high availability. So you can actually use the express route alongside the VPN in the setup whereby there is a active passive. So that means your express route will be your active line, and if in event of any failure, then that will, or connectivity loss, it will route the traffic to your VPN, which will, in terms of bandwidth wise, the express routes have superiority over the VPN. So once your network, the express route, you got a problem with it, you can then revert back to the lower bandwidth, which is the VPN, to continuously maintain the connection to your resources in the cloud from your on-prem. So this, like I said, will provide high availability if the express route circuit fails, although the fallback connection is a lower bandwidth network. The challenges you might have is that it's complex to set up, because it's not just setting up the express route, but also you need to also set up both the VPN as well, and require redundant hardware. That means having a VPN in your on your prem, you need to have a VPN that have the capability to support the redundancy element as well. So that means there's another cost element or attribute to this solution. But when it comes to network, you cannot just have a one point of failure. If you just have express route circuit without any fallback. That means you will open your server for network connectivity issues somewhere in the future. So it might be a cost involved, but then again, if this is a service that you cannot afford for it to go down, then it makes perfect sense to have that level of redundancy. Right. So let's move on to what we call the Virtual WAN. So Azure Virtual WAN is a network service that brings many network security routing functionality together to provide a single operation interface. So it's more like a mesh network where you, on your environment, more likely in your cloud, you have multiple VPN spread across multiple regions, right? And at the same time, you have multiple branch offices. And on top of that, you might probably have users that are probably working from home, and you still want them to be able to connect to these resources, what we call the road warriors, right? All of these things can be merged into one network we call the virtual WAN. And all of them can actually talk to each other. So this is more like you just think about what we call the hub and spoke, where everything is going to one point. But with this, it's spread across in a way that it's have high redundancy, highly connectivity as well. So it's a fully managed virtual WAN services. Cost savings, it give you more cost savings if you think about it, because all of these things, if you have to configure them using various technologies, that will have huge cost implement a cost effect as well. But if you're using this solution, it's more like one service that is providing you with all these functionalities. So it definitely provides some level of cost saving. So on top of the virtual WAN, you can also integrate with what we call the global transit network. So the global transit network architecture is being adopted by enterprises to consolidate and connect, control cloud-centric modern global enterprise IT footprint. So the virtual WAN support the following global transit. So can support branch to VNet, branch to branch, express route, global reach, and virtual WAN. So the key element is that even though if you have resources on-prem, you can connect to your virtual WAN. If you have and if you are using express route for that matter, that's not a problem. If you're using point to site VPN, that's not a problem. Even site to site VPN, all of them can emerge into one pool whereby there will be routes created, dynamic route created to allow all of these services to talk to each other. Designing Azure network connectivity services. So when we come to the network part, right, as you already know, the network on on-prem is the same thing that you have in a cloud. So most of the most of the things that really govern the network on-prem also govern what we have in cloud. So what I'm trying to draw at is that when you have these network in the cloud, more likely you break them down into subnet. You need to, if you are connecting from your on-prem to resources in the cloud, your on-prem subnet should be unique to the subnet in the cloud. If there is overlap, that will be a problem. All right. The same thing applies to on-prem. Each network have to be unique. If they are the same, then definitely going to be a problem going forward. So that's one thing you have to definitely keep in mind. So connecting to your on-prem network, you more likely will use what we call the VPN gateway to establish those connections to the cloud. And then once you are in the cloud with, let's say, if you have multiple VNets in the cloud, what you can do to allow them to talk to each other is using what we call VNet peering. So that means you set up this VNet peering, allow them to talk to each other. In terms of the VNet peering, they don't even need to be in the same region. You might have a VNet in, let's say, East US, another one in South UK. Using VNet peering can allow them to talk. You can even allow network that are not actually in the same subscription to also communicate as well. So that means you might probably have a partner company you work with. You probably need to integrate to their network. Then you can set up a VNet peering using their subscription as well. And in a cloud, when it comes to network, another key element is the Azure firewall. Right. So with Azure firewall, creating Azure firewall, you need to create what we call Azure firewall subnet, which will allow you to create these Azure firewall service in that specific subnet, and then you can relay all your traffic inside your Azure network to go through the firewall to provide a level of security in that perspective. Okay, so designing of the network topology, the key things you have to consider is segregation. So segregation is what? A way you can isolate specific portion of your network in a way that makes sense. So for example, if you have specific servers that do the same type of work, then you can isolate them into one pool of network. And then you might have another type of services. And the key element is this. Let's say, for example, you're looking at this one here. There is a database service, and then you probably will create a subnet. So this will be subnet one for just the database service. And then you can have your front-facing service, and you create a different subnet for the front-facing service. The key point is that when you attach a network security group to this, you only open up ports like 80 or 443. So that means traffic from outside can come in. But then when you want to then relay traffic to your SQL, you open up the port that are relevant for the SQL service. So in that case, you're not exposing your, let's say, your database to the public, because you've created this division of services based on using the subnet segmentation. So it provides security in your environment that way. And then you can still create that connectivity wise where they can still talk to each other. That another way of creating this is when you have inside your network, you want resources to talk to each other, right? Then you can use what I mentioned earlier about using the peering to set up the connection to ensure that this VNet talk to that VNet. Because by default, VNet are not going to talk to each other. Subnet within net traffic within the same subnet will talk to each other, but then you can use your own user-defined NXG route attached to those subnet to prevent them from talking to each other. Right. Another key point is the third one here, multiple network in a hub and spoke model, whereby all of the devices can all connect to one source. And then when they connect to the hub, then you can allow the hub to talk to another region as well. So that means all of them can now have connection to another region. Now let's look at designing the outbound connection. Right. So as you already know, in terms of your on-prem network, one of the key elements to allow traffic to talk to outside worlds is using NAT, because most of the traffic or most of the devices inside your network, those addresses they are using the private IP addresses. That means they are not routable over the public internet. They need solution like network address translation to simplify the outbound traffic to the internet. So there are many options when it comes to using NAT. You can use Azure Firewall to create the NAT, or you can even use a load balancer to create the NAT as well. And also there are dedicated virtual network NAT gateways that you can use to create the NAT. And then once the NAT is created, you can obviously specify a public IP address that will be linked to it. So that means traffic leaving the network, the internet network will relate to that public IP address, and that will be the IP that is public facing. And once the traffic gets back in, then using the NAT table, you'll be able to relay the traffic back to the device that the traffic originated from. Let's look at designing routes, right? So when it comes to creating a virtual network for the first time without defining any subnet, Azure creates route entries in a routing table, right? So, I mean, those routes are system route created by based on the service you've created. So the subnet will by default be able to talk to another subnet based on the system route created in there. And traffic will be routed to the public internet, because once you create a subnet or VNet, automatically those are defined as well. Right. But then you can also create what we call the user-defined route. And the reason is when you probably want to forward all traffic through a firewall or network virtual appliance. So if you have a third-party firewall that you deploy on Azure, you don't want to use Azure firewall. Even using Azure firewall, you can use your own user-defined route to forward traffic through that. So that means you are defining your own route. And equally, you can also decide that, okay, I do not want my subnet to talk to each other. Then you can create your own user-defined route to prevent that from happening. So that means one subnet will not be able to talk to each other by using your own user-defined route in that way, right? And these are the types and the priority of route. So your user-defined route will take precedence over a BGP, the border gateway route, and then the system route will be at the very bottom. So when you define your route, it's always going to have more weight than the system routes that are created by default. So let's move on to application delivery services. So one of the solutions that many companies will deploy or use is what we call load balancing. And in Azure, there are multiple or various load balancing services. So we do have Azure Front Door, Traffic Manager, Load Balancer, and Application Gateway. And there are many scenarios where you might want to use these services. Traffic type. So depending on the traffic, whether it's TCP, UDP, HTTP, HTTPS will now tell you which sort of load balancer you're going to select. For example, if it's TCP traffic, then you need to use the load balancer, which is layer 4, sort of like when you look at the OSI model, this would be a layer 4 layer 4. So you need to ensure that you need to understand what sort of traffic you are dealing with. Another key point is global versus region, right? What we mean by global versus region is this, right? Some of these load balancing solutions can only route traffic based on a region. Key point is load balancer and also application gateway. So these are regionally based, right? Compared to Azure Front Door and also Traffic Manager, which are globally based services, right? So you also have to think about high availability. Most of these services can actually be used together, right? You can mix them in that way. and the cost element aspect of it as well. So the whole thing is all about that. Most of these services can do what the others do. So they can probably do the same thing, right? But you have to also look at cost. Does it make sense to use a costly service for something that can be done by another service that will cost you cheaper, right? So you have to think about it. Another thing is the features and the limits. So for example, with Azure Front Door and also application gateway, it gives you a level of security like WAF, web application firewall, or DDoS protection mitigation services. So you need to always continuously think about how well those services will actually suit into your architecture. All right. So we have this flow chart whereby it gives you an idea of what sort of service to pick up based on what exactly you are trying to implement. So let's look at this one here. So when it's a web service, for example, you can understand that you probably will have to look at it this way. Is it internet facing? Right. If it's not, and then you also have to know that once it's not, then you have to be Azure load balancer, right? When it comes to here, when you say it's a web application, right? Yes, it is. So that means HTTPS traffic. You have to consider, is it an internet facing application? If it's no, then application gateway will be enough to do your job. That means you are saving your money, right? In this scenario, when it's internet facing, then it's a global and deployed in multiple regions. Traffic manager will be the appropriate service. So following through this chat will definitely give you an idea of how well to use the right service to do the right job. So now let's look at the various services, the various load balancers. So when it comes to the service load balancer, it have high performance, low latency load balancing, and it's for the UDP and TCP protocols. That means layer 4 load balancing, and you can manage the inbound and outbound connection. It can be used for internally load balancing resources internally, and also for load balancing traffic for your endpoint externally as well. So you use this rule to map the inbound connection to the backend destination, and by leveraging what we call the help props, you can identify when a specific endpoint is not functioning well. So that means the help prop will be able to identify that, okay, I'm not getting any response from this specific endpoint, so I no longer have to route traffic to it unless it comes back up. That means unless I start to receive healthy signals from that specific endpoint, then I start to route traffic. So in that way, you are rest assured that your environment are more highly available. Let's look at application gateway. So application gateway is a web traffic load balancer that enables you to manage traffic to your web application. It is an application delivery controller as a service. And with this offering, this is a layer 7 offering. So that means HTTP and HTTPS. And some of the key benefits that you get for this one is more like you support WAF. That means with a WAF, you are able to identify any of these known exploit like cross-site scripting, buffer overflow. What the other known one that we see a lot is what the SQL injection. These will be able to, using the WAF, you'll be able to identify these type of exploits, and then it will block those type of connections. Another thing is traffic routing. So what this one does is that it can be used based on a specific URL. So that means you can have multiple services on the same server, and then it can route the traffic based on wherever the URL is to a specific server. All right. That means you can also leverage upon the performance. So some scenarios, you might have a server that is highly tuned with better resources like better CPU, better RAM or memory so you optimize it for certain functions. So if for videos, you route all the video traffic to that server. So when the traffic is coming in and there's a slash video, then it grew to that specific server. So it helps you in that way. So that means it's much advanced compared to the load balancer, to be fair. So this one also support platform as a services, and also we support IPS. Right, and these services are also regional based. So that means it's restrictly to a specific region. Now, with your infrastructure, as you grow as a company, you have to understand that we are in an era where people want to have access to resources as quick as possible. So as an organization, especially with the e-commerce organizations, you don't want to take chances where the service is slow. So most companies will now have to start leveraging what we call the content delivery network, whereby rapidly with high bandwidth, certain type of your servers are cached into strategic places around the world. Which the benefit aspect of it, this one is that, let's say your customers are based in let's say India, all right? You want your resources to have what we call the point of presence, whereby your servers are cached in a specific location, what we call point of presence, POP. That means whenever those people or that specific location try to access your resources, it's not going to go all the way to the original point where your service is located, but rather it will go to a point of presence or a server that is close to those end users. And as you know, in terms of network wise, the less sort of like the way it travels, then that means they will have higher throughput. That means they will get access to those resources in a quicker way, right? So companies have started to leverage on these content delivery to help to enhance their connection for their end users, to make sure their traffic are highly, available to their customers. I know like probably about 20 years ago, people were used to, slow internet connections, slow delivery of services. But these days, everyone want to get the resources as quick as possible. So leveraging content delivery network will help to bring your organization in tailor with a modern way of doing things. Azure Front Door. So with Azure Front Door service, this enables you to define, manage, and monitor global routing for your web traffic by optimizing best performance and instant global failover for high availability. Right. What this one means is that this is a global service which have different metrics of how you can prioritize those traffic. So you can use performance based, whereby traffic is routed to a specific, just like the CDN, a specific region which is close to your users, meaning they get the services quicker. Or you can also use priority base, whereby you have a specific primary server and say, okay, all my traffic route to that specific server, and then there's a secondary backup. You can even use wait, where you can have equal distribution of the traffic to a set of servers that you do have. So the key point here is that there are many ways you can define how you want your traffic to function. And on top of that, you can take advantage of the WAF that comes with Front Door. And with Azure Front Door, the CDN is also integrated into it as well. Traffic Manager. So with Traffic Manager, it's a DNS-based traffic load balancer. So that means whenever you use a Traffic Manager, it's using a DNS query, right, to use it for their distribution of the traffic, right? And one of the key benefit of using the Traffic Manager is that just like the Azure front door, it also use various ways of distribution your traffic. It can use priority, also can use weight, performance, geographic, or multi-value. So let's look at a few of them, right? So for example, performance, like I said earlier, is all based on um, the specific location of the customers, and then traffic will be whenever they try to reach out to your resource, they will connect to a server close to their region based on the logic that is in the Azure Traffic Manager. Geographic location is more like data sovereignty, whereby in some organization, if they have customers in US, maybe there is a demand that they have to have their resources in also a US region. So that means when their customers try to access their resources, it will go to that specific region, and that region, the server in that region, will deliver their resources to them. In terms of weight, those are distribution of the traffic evenly across the service they have, or they can decide to have more weight on a specific server than the other. So it give you more flexibility on how you distribute your traffic. All right. So to increase your application availability, improve your application performance, combine even hybrid application, and also distribute traffic for complex deployment as well. So let's go into the protection services. So when it comes to Azure Network, you can obviously host multitude of services like AKS, Azure Kubernetes services. You can even have, I think, I think you can also have, normally probably you'll have your endpoints in there. You can also have your Kubernetes services, service fabric as well can be in your virtual network. But there are certain services that cannot natively to Azure that cannot be put into the virtual network. For example, for your storage or your SQL database, those cannot be gone into the network, Azure network. But then you can use solutions like or services like the endpoint, service endpoint. This will allow your virtual network to be able to talk to services like what I just mentioned, service like your Azure storage, as an example. So this improves the security to those resources, and the reason is this: you can choose to block access over you can block users from accessing, let's say, the storage via the internet, but then you can use the service endpoint to allow those virtual network to talk to those resources, like Azure storage. So what this one will do as well is that it will leverage the Azure, it will leverage Microsoft Backbone network. That means those traffic will not traverse over the public internet, but rather through the Microsoft Backbone. Another one that is also critical when it comes to connecting your virtual network to resources on Azure, like Azure Storage or SQL database, is using what we call a private link. This enables you to access your platform as a services, so, Azure Storage, SQL database, and even go extra further, whereby it can allow you to access your hosted customer own or partner services as well. All right. So private link is used to access platform as a services such as storage, Azure SQL, Azure App Service, and many more. Right. So the recommendation is that you need a private connection to those services, and you need to integrate with on-prem peer network. So this will allow you in those scenarios to use the Azure private link. in terms of security in your network, one of the key ones that you can leverage on is the network security group, right? So with a network security group, what this one will do is that it will have you open up specific ports you want to be accessible by different type of resources. So a key point is that you probably will have a subnet, and then you attach as a network security group to open up, let's say, just port 80. So that means all other ports will be blocked. And you probably will have a different subnet, and you attach a different network security group and open different set of services to those resources. So what this one is doing is that creating the security in your environment to protect you against any form of attack, because you are really opening up just specific services. And if you can limit it to a specific IP or even a specific group of network as well, if you choose to. Azure Firewall is also something that many companies will leverage, because in your on-prem environment, you more likely will have a firewall. So the same logic applies here, whereby you can use a firewall to provide inbound protection for non-HTTP traffic. So for example, for RDP, SSH, FTP, outbound network level protection for all ports. Right, so you can leverage Azure Firewall for that purposes. And the way this one works is that they actually implement it based on the priority. So that means you set up multiple policies, and once one, it's more like first hit, then it stops. So whichever hits first, the traffic hits first, that it matches, then it will obey whatever a policy you have configured for that. So that's one of the key things when it comes to when you're setting up your Azure Firewall, you have to bear in mind. Web application firewall is also one of the critical components, especially when it comes to e-commerce companies. You always want to have this web application firewall in place. And this one will protect you against common web exploit and vulnerabilities such as SQL injection, cross-site scripting. And with Azure OAuth, it provide out-of-the-box protection for OAuth's top 10 vulnerabilities as well. So many companies will always want to leverage this to really have those sort of inbuilt protection in their web services, because the bad actors are continuously trying to find a way to get into your network. So you need to know that the ones that are already been identified and most of these bad actors are using, you more likely have to have a way to protect yourself against that. And this WAF will provide you just that. DDoS protection. Now, many companies always want to maintain continuous business. Continuity of business is really important. So when you think about continuous business, you also have to think about DDoS protection, because DDoS protection is more like ensuring that no bad actor can try to find any ways to overwhelm your network. So it will provide countermeasures against any sophisticated DDoS threat. The service provides enhanced DDoS mitigation capability for your application and resources deployed in your virtual network. So using a DDoS, you'll always protect yourself against adaptive. You always protect yourself against any sort of like overwhelming of your network. So there is adaptive tuning, whereby it will continuously monitor your network to identify any volume of traffic coming in the way that it probably will be deemed as a DDoS, and then to protect you against that. And also there's a multi-layer protection. That means you can have different layers of protection in place. If you have, let's say, NXG in the mix as well, providing extra level on top of the DDoS. And then on top of that, you might have a WAF protection as well. So having different layer of protection is really comes a long way. Azure Bastion is also one of the key things that as an organization, in terms of deployment of your network, you need to also consider, because the bad actors know that the common services people use to remote into their services, they might use um, uh, RDP, or they might use SSH, right? So rather than sticking to this common known way of connecting to your service, you can leverage the Azure Bastion, which is a fully platform managed, a fully platform as a service provider that will help you to manage connectivity to those web servers you have inside your network over the TLS. That means using the 443 connection for that matter. So that will give you an extra level of protection.
Yeah,
Yeah,
sorry, Sir
sorry, Sir
Kofi,
Kofi,
to
sorry
cut
to cut
you a
you
bit
a bit
short.
short.
We have we are
We are
about
about
rounding up.
rounding up.
I
Okay.
don't know
I don't
if
know
you
if you
could.
could.
Yeah.
Yeah.
Yeah,
All right.
absolutely. Yeah, so we already got to the security part anyway. So I think this will be the last slide. Just in time is another crucial way of providing level of security. Only providing only providing access to resources at a specific time, and then removing that access when it's no longer needed is becoming very important. So that means your network is very dynamic in a way that you provide access at a specific time and then you remove it when it's no longer needed. That means a bad actor trying to get into your network will no longer have access to it, because if that port is open all the time, that means a bad actor can take advantage of that. But then with this, using just in time, you only provide the access and you know who you're providing the access to at what specific time the access is needed. And once you give the go ahead, they get the access, and then they no longer will have it anymore when the time expires. So just like Promise said, it's been when it comes to the networking design, there's many components to it. So it takes time to really get into all of this. So I hope what I've gone through today is enough for you to really understand what this is all about. As always, if you have any questions, you know how to get to me. You can reach out to me on my LinkedIn page, or probably you can still reach out to me via the community as well. So thank you for taking the time of your day to really join this session, and I hope you've learned something from this. So thank you very much, everyone. Promise?
Thank you
Thank
very
you
much,
very much,
Sir
Sir
Kofi.
Kofi.
I would
I would
say
say
that this
that
is
this is
quite
quite
interesting.
interesting.
I actually
Actually
gained
gained
one or
one
two
or two
things.
things.
Just
Just
before we
before we
round up
round
the
up the
session,
session,
right?
right?
There is
There is
this
this
do I
do I
call it
call it
a
a
hub and
hub and
spoke
spoke
kind of
kind of
thing that
thing that
goes
goes
on
on
between.
between.
Okay, I'm
Okay,
trying
I'm
to
trying to
paint a
paint a
picture of
picture of
where
where
we are
we are
trying to
trying to
connect
connect
maybe
maybe
two
two
environments on
environments
your
on your
Azure
Azure
solution,
solution,
right?
right?
And
And
these
these
two
two
environments,
environments,
they
they
have
have
two
two
separate
separate
VNets,
VNets,
and
and
then
then
you are
you are
able to
able
make
to make
use of
use of
VNet
VNet
peering
peering
to be
to
able
be
to
able to
pair
pair
them so
them so
that
that
machines on
machines
these
on
two
these two
VNets
VNets
can
can
communicate.
communicate.
Now,
Now,
as
as
your
your
environment
environment
keep
keep
growing,
growing,
right,
right,
and
and
you keep
you keep
having
having
more
more
VNets,
VNets,
what would
what
you
would you
suggest is
suggest
a
is the
best way
best way
to
to
interconnect
interconnect
all of
all
these
of these
VNets
VNets
together
together
for
for
easy
easy
flow
flow
of
of
communication
communication
between the
between the
machines
machines
on these
on these
VNets?
VNets?
All right, so that's a common question that many companies will more likely will face, whereby at some point your network keep growing, you have branch offices joining into the whole network chain. You might have people working from home, all of them connecting to, but you want all of them to talk to each other. So when it comes to that, one of the services that can obviously provide you a level of coverage across the whole board, including all the VNet you have in different regions. All the root warriors. That means users that probably were using their mobile devices to connect as well, and all the branch offices. Site-to-site connection, point-to-site connection. For you to integrate all of that, you will need the virtual one. So the virtual one as a service will provide you that level of connectivity in a complex mesh network. Because what that one will do is that you can have multiple hubs. So depending on where that specific branch office or that specific VNet is located, all of that will connect to that hub in that specific region. And once it connects to that region, then it will be able to use the hub to hub connectivity to ensure that all of these devices are interconnected. So in your scenario, what you describe, the virtual one will be the right solution for this job.
Thank you
Thank
very
you very
much, Sir
much, Sir
Kofi.
Kofi.
Before I
Before I
proceed, please
proceed,
can
please
you
can you
mute your
mute your
mic?
mic?
Yeah,
Because
absolutely.
Because I think,
yeah, I
yeah, I
think
think
whenever I'm
whenever I'm
speaking,
speaking,
I'm
I'm
getting like
getting
some
like some
feedback
feedback
Oh, okay.
from your
from your
speaker.
speaker.
All right,
All right,
okay.
okay.
So
So
I
I
mean
mean,
that
that
was a
was a
very
very
nice
nice
solution
solution
you
you
mentioned,
mentioned,
right?
right?
I
I
mean,
mean,
I
I
think
think
for
for
me
me
and
and
some
some
other
other
people,
people,
they may
they may
have
have
experienced this
experienced this
challenge,
challenge,
and
and
I
I
mean, you
mean, you
just
just
give a
give a
solution to
solution to
that
that
particular
particular
issue,
issue,
right? So
right?
I
So I
mean,
mean,
that's a
that's a
beautiful
beautiful
one.
one.
That's a
That's a
beautiful
beautiful
one.
one.
So at
So
this
at this
moment, I
moment,
want
I
to
want to
say,
say,
Sakofi,
Sakofi,
thank you
thank you
very
very
much for
much for
this
this
wonderful
wonderful
session
session
which you
which you
have
have
led us
led us
through.
through.
I
I
mean, it
mean, it
was
was
interesting,
interesting,
and we
and
do
we do
hope
hope
to,
to,
continue
continue
on the
on the
series.
series.
So
So
thank you
thank
very
you
much,
very much,
Sakofi.
Sakofi.
It
It
was
was
nice
nice
speaking with
speaking with
you.
you.
Okay. So at this point in time, I would be rounding off the session, right? And just like Sakofi mentioned earlier, one of the beautiful things you can do when you're struggling with, how to interconnect your VNet is actually making use of the virtual one. This will help you to be able to interconnect your multiple VNets which you have in your environment. So, I mean, this series will definitely continue. We'll definitely have more series like this. So, stay tuned. If you haven't joined our channel, subscribe to our YouTube channel, please do so. If you haven't followed our LinkedIn page, please do so. If you haven't followed us on Meetup, please do so. I mean, I think we have like a flyer for this, but I mean, I'll be sharing them during the course of the session. But for now, we want to just round off this particular session for today, and we would just like to encourage you to tune into our channels, be updated with what is going on. For every program which we're going to be holding, we're going to be sharing it on our LinkedIn page. So please endeavor to follow us on our LinkedIn page and be updated. You can also search for Sakofi on LinkedIn, and get to connect with him, and then ask him more questions if you would like to gain more insight on networking solutions and all of that. But for now, I would like to say thank you very much for staying with us all through the session, and have a good day. Enjoy the rest of the weekend and the Easter season as well. Thank you very much. Bye bye.